Welcome to Unit 1 Trigonometry. Today we're going to look at primary trig ratios, sine and cosine law, which should be a review for you, at least hopefully you remember by the end of the lesson. Take a second to read through those learning goals before you begin. For our primary trig ratios, remember that primary trig ratios only applies to our right angle triangles, so remember to look for a little box that shows that it is a 90-degree triangle. If it doesn't have that box, you know that it isn't 90 degrees and you cannot use your primary trig ratios. When we look at our primary trig ratios, remember that we're using our acronym Sohcahtoa. Sohcahtoa helps us to set up our ratios in order to solve a problem. So for SO, you have your sine, which is your ratio of opposite all over hypotenuse, that O and that H. Cosine, which is that adjacent over hypotenuse, the A over the H, and then tan, which is our over A, which is our opposite over adjacent. So that helps us in solving our question, as well as labeling a triangle. We need to look at our reference angle, which is denoted as theta here. Which is denoted as theta here. And to label that, you're going to always label across from your 90-degree triangle is your hypotenuse, always. That never changes. Across from that reference angle of theta is going to be your opposite. So your opposite side does not touch your reference angle ever. And then adjacent's kind of that leftover side, or it's the side that does touch that reference angle there. Some information just down at the bottom there that is key to remember is that when you're finding a side, we're just going to simply use sine, cosine, and tan. But when we have to find an angle, we're going to have to use that little exponent -1, which means that it's sine to inverse, cosine inverse, and tan inverse. And then also please make sure that your calculator is set in degree mode. It should have a D at the top or say DEG. If it doesn't and it says R or something different, you need to make sure that you ask me or try to reset it on the back of the calculator. We're going to look at solving a triangle for this example. Solving a triangle means that you need to find all unknown sides and angles. It doesn't mean that you can choose. So for this example, we need to find side X, side Y, and also angle theta. Probably easiest for our example to start with finding our angle theta, because if you remember what a triangle adds up to, it's 180 degrees. So you can take that 180 degrees, just subtract that right angle, which is 90 degrees, and subtract that 60 degrees, and you should get 30 degrees in your calculator or with mental math. So by doing that, that kind of sets you up to have a nice triangle that you can actually use either 60 degrees or 30 degrees for your reference angle. Remember not to use that 90 degrees for your reference angle when using Sohcahtoa. So let's just use our 60 degrees for our reference angle, and let's find side X first. Doesn't really matter here. You could find side Y if you wanted first, but I've just chosen side X. So with that, remember, we're using our 60 degrees as a reference angle, which means that opposite it is the 16, so you're going to mark that with the O. Opposite your 90 degrees is your H, and then your leftover side is your adjacent. Remember, adjacent also touches that reference angle of 60 degrees. So looking at your acronym Sohcahtoa, we know that we need to find our adjacent side, so it needs to be either Ka or Toa, but we also have no information for our hypotenuse, so you can eliminate that H. Because our Y is something else we need to find, you don't want the X and the Y in this example, because then you have two unknowns and would be impossible to solve. So you want the one with the opposite and the adjacent, so that's going to leave you with tan. So you're going to set that ratio up by doing tan theta is equal to opposite all over adjacent. You know that in this example, your theta, your angle, is 60 degrees. And then you know your opposite side is 16 meters. And your adjacent side here is marked as an X. An easy way to remember, just want to switch my pen color. An easy way to remember what to do is you're just going to simply take the tan of 60 and take that x, and you're going to switch them. Their exact place in where they are. So you're going to put the x where the tan of 60 is on that left-hand side. You're going to take the 16, and then you're going to take the tan of 60 and put it where the x was, and now it's in the bottom of the denominator. Now, all you're going to do on your calculator is press 16 divided by tan of 60, and you should get approximately 9.24 meters. Make sure that you put that meters there if it is given to you up in your triangle above. For finding our side y, which is next, you are going to use the exact same reference angle and label of your triangle if you want. So let's use the 60 again. We'll use our opposite, and this time we want hypotenuse. So we have opposite and hypotenuse, so you know that we're going to use our sine ratio. So again, we're going to use 60 degrees, and we have our opposite and our hypotenuse. So we're going to do sine of 60 degrees. Our opposite side still is 16 meters. That doesn't change, and our hypotenuse is labeled as a y. Again, all you're going to do is simply switch that order, and you're going to put the y where the sine 60 was, keep the 16 where it was, and put the sine of 60 to below. And then you know that y is equal to approximately 18.5 meters. It should be your longest side because it is your hypotenuse. Into solving some word problems with our primary trig ratios is that you need to remember what the angle of elevation is and what an angle of depression is. A good way to remember this is that you always think of them from the horizon. So if you were standing and you were looking up and you were told that an angle of elevation is like 30 degrees, then you know that it is from the horizon up. If you're told an angle of depression is 30 degrees, you know that it is from the horizon down. So again, we'll see this in examples. It's just you need to remember angle of elevation goes up and angle of depression is going to go down. Trig ratios, we have a 10-foot fire truck that has an aerial ladder mounted on it. The ladder can extend to 101 feet. The angle of elevation of the ladder is 63 degrees, so there's that language that we just talked about on the previous slide, and it wants to know how far up the building can the ladder reach to the nearest foot. So here where the B is, the side B is labeled, would be our building. So it wants to know how far up our building the ladder can reach, and for that, you know that you are going to be finding that B. Okay, you know your hypotenuse is going to be across from your 90 degrees, so you can label that H, and you've been given that angle of elevation of 63 degrees, and you know that opposite that is going to be your opposite side, and where that fire truck is going to be your adjacent side because it's attached to that reference angle of 63 degrees. Right now, this 10 feet doesn't really come into play because it's not in our triangle yet. So when using Sohcahtoa, you have to figure out your ratio that you're going to use, and you haven't been given any information for that adjacent side. So you can't use ka and you can't use toa, so you're going to use sine. So here is your sine ratio. So sine theta is opposite all over hypotenuse. And then remember that you are given that reference angle of 63 degrees. And then your opposite side, which is B, all over your hypotenuse, which is 101. For this one, we can't switch sine of 63 and sine of 101 because it would just switch the place and we wouldn't still be able to solve it very nicely. But another easy method, so if you have the number on the bottom, what you're going to do is you're just going to take it up to the front of here and you're just going to actually multiply it. So rather than dividing like our solving triangle before, you're just going to multiply. So it's going to become 101 times the sine of 63 degrees is equal to B. When you put that in a calculator, you should get approximately 89.99 degrees, sorry, not degrees, feet, which is equal to B. But then remember that we also have this 10 feet. So this whole side from the bottom here up to the top of A is 89.9, but you also need to account for that extra 10 feet here. So you're going to have to add 10 feet to it. So then technically that whole wall is 99.99 feet is equal to B, or you could say 100 feet. I'd let you round that because it's so close. Okay, so just knowing that, you've solved your first word problem. So you would write, therefore, the ladder reaches 100 feet up the wall. Oops. There we go. For sine law, remember that it applies to non-right triangles only. So you don't have that little box that shows you that there's a 90 degree. So you know you're going to have to use sine law or cosine law, but we'll start with the sine law. So you're either given two angles and a side or two sides and an angle, but remember that the angle cannot be contained, which will make more sense when we go over cosine law because you won't be able to use sine law anyways if it is. Okay, I've written the sine law here two different ways. So the first way I have the sides on top and the angles on the bottom. It's easier if you're finding a side. If you put the angles on the top and the sides on the bottom, it's easier if you're finding an angle. So remember our lowercase letter is a side, and then the one that has the sign on top of it with the capital letter is going to be your angle. So just remember that if you're finding a side, it's easier to use the side on top, angle on the bottom, finding an angle, angle on top, side on the bottom. It doesn't really matter. It just makes your math a little bit easier when you're doing your sine law. So for your first example, we're going to find side x, which means that we need to label all of our sides. So remember, across from our angle x is our side x, across from our angle y is our side y, and across from our angle z is our side z. They're always across, they're never attached to the actual angle. Okay, so we're finding side x, which means you're going to have your side on top and your angle on the bottom for your ratio. However, we know that we only ever need to use two of these. It would be very complicated if we had to use all three. So we're going to find out what information that we're giving, the sides and angle, that we're given some information for. And we also know that we need to find side x, which means that we need to know angle x. But right now we currently don't, but it's actually quite easy how to find it. So remember from our one example, triangle adds to 180 degrees, so you're just going to subtract that 34 degrees and subtract that 52 degrees, which is equal to 94 degrees. And then you can use that for your ratio. So you know that you're going to have x, we don't know, but we know that we're going to have our angle x, which is 94 degrees. And then the other one that we have two pieces of information for is that angle z and side z. So we're actually going to get rid of our y ratio, and we're going to use z instead. So we know that it's 18 all over sine of 52. And then you're going to simply cross multiply. Let's go blue. So you're going to multiply x times the sine of 52 and 18 times the sine of 94. And when you do that, it will be written like this. So you're going to have x sine of 52 is equal to 18 sine of 94. And then you're going to take and get rid of that sine of 52 that's multiplied to the x. So because it's multiplied, you should know that you're going to divide it out because you do the opposite operation. That leaves that sine of 52 canceled out, just left with an x, and you're going to put 18 times the sine of 94 divided by sine of 52 into your calculator, and you should get approximately 22.8 or 23. We aren't given any units here, so that's okay. You just are going to leave it as that. Make sure you put that little dot above your equal sign to show that it is approximately, and then you can do a therefore statement saying therefore side x is approximately 23. And you are done. So for our next example, we're going to look at finding an angle. So this time we're going to want to find angle y, which is really nice because across from it we have side y. And then our other ratio that we have is that x. So we have side x and angle x. We have nothing for z, so we really don't want to use z. And it saves you a little bit of writing out, so you can just write out the two ratios. So you're going to find y, so you're going to go, remember that we want to use our angle on top. There we go. So you're going to do sine y on top, all over angle y, side y. And then you're going to do sine x all over side x. So for sine y, remember we do not know our angle yet, so we're going to leave that blank, but we do know our side. So you're going to put 25 in there. You do know your angle x, which is 95 degrees, all over that side, which is 38. And then you're going to simply cross multiply again. This time it's going to look a little bit different after you've cross multiplied. So you're going to get 38 sine y is equal to 25 sine 95. And then we're going to divide by 38 this time because it's multiplied to that sine of y. But then you're still going to be left over with sine y on that side, which is fine. But do a calculation first, and you're going to do 25 sine 95 divided by 38, which is going to be approximately, you should get a decimal number here, 0.65539. And then, remember, finding an angle, to get that sine to the other side, we need to take the inverse of it. So you're going to take the inverse of that number. It's easier probably if you leave that whole number in your calculator as well and just write down a couple of the numbers. And then you should get approximately 40.95 degrees, or for an angle you usually want to round to the nearest degree, so 41 degrees. So you put approximately there, but remember that you usually round an angle to the exact degree. Therefore, angle y is approximately 41 degrees, and you are done. So for the cosine law, remember again, non-right triangle, and you are given two different pieces of information. So you're either given one angle and two sides to find another side, which means that it has to be contained, which means if you're given a triangle, sorry, it kind of looks like a 90 degrees, but here's your angle that you're given, you would know these two sides. That is a contained angle in between there. Or you may have heard of embedded angle as well. But it has to be between two given sides. Or you're given three sides to find an angle. Here, I again have written them nicely for you. This is easiest if you're finding a side because you have that side on the left-hand side. You have that A over here. And then this one is easiest if you're finding that angle because the angle is on that left-hand side. Remember that all of these can be rearranged. So a squared is equal to b squared plus c squared minus 2bc cos of a can be rearranged to b squared equals a squared plus c squared minus 2ac cos of b. or it can be arranged for C. If you don't remember how to rearrange those, or you can't find it on the internet or anything, or in your workbook, then you can ask me, but you're simply following the exact same pattern and just rearranging it for either side B or angle B, or side C or angle C on that left-hand side. For your first example here, we're going to find angle B. So in this case, we are given 3 sides. Okay, so for when you're given 3 sides, you know that you're going to want to use your cosine of B on the left-hand side, and then it is going to be a squared plus c squared minus b squared all over 2ac on that right-hand side. What you're going to do is just, again, label your triangle. So side A is that 17, side C is that 14, and side B is that 19, which makes it easier to fill into your formula here. We don't know our angle B. Obviously, we are finding it, but we know all 3 of our sides. So side A is 17. You're going to square it, plus side C, which is 14, square it, and minus that B, which is 19, and you're going to square it. And you're going to do 2 times 17, which is your A, times 14, which is your C. You're going to keep that cos of B, and then you can plug this in on your calculator. So 17 squared plus 14 squared minus 19 squared, you should get 124. And then 2 times 17 times 14, you should get 476. With that, remember to get rid of the cosine attached to that B. You're going to do the inverse cos of 124 divided by 476, and you should get approximately 75 degrees. So you've solved that angle B is 75 degrees there. You could be asked to find the other angles in here. If you had to find angle A, then you'd have to do this whole thing again. But then to find that third angle, it would be quite easy because you can just do that 180 minus that 75 and then whatever minus that angle A is. But for this example, you're just asked to find one. For our next example, you can see that we're asked to find a side, which means to use cosine law, we need a side and a side with an contained angle. You know the 2 sides, and the angle in between them of the 2 attached sides is 43 degrees. So you know that you can find side A using our cosine law. So to do that, you're going to have your a squared on that left-hand side. You have b squared plus c squared minus 2bc times that cos of a. This side, A, will always be angle A here. That's a way to try to help you remember if you are rearranging for B or C. Okay, so our A, we don't know, so keep it there. But we do know, let's label our triangle. So let's just go, this is B and this is C. So let's go, this is side C and this is side B. Make it a little bit easier for you, but it is just the 2 sides. So you're going to go 7 squared plus 5 squared minus 2 times 7 times 5 cos, and then your A there is 43 degrees. You're going to sub that in, and then be careful when you're solving this. So you're going to get 49 plus 25 minus 2 times 7 times 5, which is 70, cos of 43 degrees. And where a lot of students go wrong here is they'll do 49 plus 25 minus 70, but you can't do that. The 49 and the 25 have to be added together, and then this 70 needs to actually be multiplied by that cos of 43 because of bed mass. So you're going to go a squared is equal to, and then you have 49 plus 25, which is 74. And then when you do 70 times the cos of 43, you should get about 51.1947591. Easiest and best, most accurate results is if you keep all of your decimal places, or at least keep them in your calculator. You're going to go a squared, and then you're going to do that 74 minus that 51.1947591. So you should get approximately 22.8 0.05 to 4.089. And then remember, get rid of a squared. You're going to square root it, and then you're going to be left with just a, and then it's approximately 4.8. So you've just solved for that side. So therefore, side A is approximately 4.8. Again, no units given. You could give it units if you want, but since there isn't any, you don't have to. Our last example here is a word problem. So here we have a hiker that walked 4.9 kilometers due north, which means she would have walked from here and went straight up from her campsite. So you can see that the campsite would be down here. Then she walked further 5.8 kilometers. So you can see the 5.8 kilometers here at a bearing of 110 meters. So she basically turned around and went back 110 meters. How far from the campsite is she now? So she would have walked 5 kilometers, so she would be here. So now they want us to figure out how far she is from the campsite. So this is going to become our, let's say that's our A. So we can label our triangle A here. Let's go, this was C for campsite, sure. And then this is B and little b. It doesn't really matter which one you label A, B, and C. You're still finding, as long as you're finding this side, you're fine with however you label your triangle. So since we're finding side A, we're going to do our A squared equals B squared plus C squared minus 2BC cos of A. And right now we're good. We have our side B and our side C, but we don't quite have this angle A yet. So to get that angle A, you're going to want to do a calculation. Remember that a straight line is 180 degrees. So to get that bearing of 110 degrees there and figure out what's left over here, you are going to do 180 degrees minus that 110 degrees, which gives you 70 degrees. Okay, so when you do that, now you can use that. You can't use that bearing of 110 degrees because it's not in your triangle. It's got to be in your triangle to be able to use. Okay, so now that you have that, you can sub in all your information and solve just like one of those previous problems that we just did. So keep your A squared. Our B is 4.9. So you're going to go 4.9 squared plus 5.8 squared minus 2 times 4.9 times 5.8 cosine, and then use that 70, not that 110. Again, you're going to do 4.9 squared plus 5.8 squared, which is 57.65, minus 2 times 4.9 times 5.8 cos of 70. You can actually just multiply all these together. Again, that's another little shortcut. So that is going to be 19.44 if you do that. And then you're going to subtract those two numbers to give you about 38.21 and square root them, which gives you A, which is approximately 6.18 kilometers. And you do have units here because she has walked 4.9 kilometers and 5.8 kilometers. So therefore, the hiker is 6.18 kilometers from her campsite. And you are done that question. So now for homework, it looks like a lot, but remember we did just review primary trig ratios. There are some word problems which are 3D word problems. You would have done 3D word problems last year. They're really no different than 2D word problems. So attempt them, ask me if you have any questions. For page 17, it's all sine law questions, and page 20 is all cosine law questions. So maybe if you want to start with what you don't know, or maybe you do want a little bit of review and want to start with your easy primary trig ratios, it's up to you. Looks like a lot of homework, but remember, it is just review. So if you are remembering stuff, you can skip over some of the questions if you want, but try not to skip over too many because practice is perfect and you're going to need to know these. All right, there's your first lesson done. Good luck on your homework.